When the temperature hits 32 degrees Fahrenheit, every homeowner's mind jumps to one thing: their pipes. We've all heard the horror stories and seen the pictures of burst copper pipes and the absolute nightmare of water damage that follows. It's a very real and a very expensive threat, but what if I told you that while you're laser focused on your plumbing, there are at least 9 other critical systems in your house that are silently on a collision course with their own catastrophic failure? These are the hidden dangers, the ones that don't make the headlines but can leave you cold, in the dark, and staring at thousands of dollars in repairs. I learned this lesson the hard way a few winters back. It was one of those bizarre winter weeks, bitterly cold, then a sudden thaw. I figured the worst was over, but what was happening outside was creating a time bomb in my basement. You see, the discharge line for my sump pump, the pipe that carries water safely away from my foundation, had frozen solid during the cold snap. When the thaw came, groundwater started rising, and the pump kicked on, just like it's supposed to. The problem was, the water had nowhere to go. The pump ran and ran against a solid block of ice until the motor completely burned itself out. I had no idea any of this was happening until I walked downstairs to a half-inch of frigid water spreading across my basement floor. It was a gut-wrenching, expensive, and, as I learned, an entirely preventable disaster. That experience sent me down a rabbit hole, and what I discovered is that our homes are a lot more fragile at the freezing point than we think. Today, I'm walking you through the 9 hidden systems that are at risk and giving you the simple checks you can do right now to keep your home safe, warm, and dry all winter. Number 1. Water pipes. Alright, let's start with the one everybody thinks they know, but let's talk about where people get it wrong. Number 1 is, of course, your water pipes. The reason this is such a notorious problem is simple physics. When water freezes, it expands by about 9%. This expansion puts thousands of pounds per square inch of pressure on whatever is holding it. That kind of pressure can split copper, PVC, or even steel pipes like it's nothing. Then, when the thaw comes, that tiny crack turns into a fire hose, dumping hundreds of gallons of water into your home, leading to collapsed ceilings, ruined floors, and a massive mold problem. The cleanup from a single burst pipe? We're talking $10,000 or more. Easily. Now, to protect the obvious pipes under the kitchen sink, in the bathroom. But where do people get blindsided? It's the pipes they forget. Think about the water lines running to your washing machine, especially if it's in a garage or an unheated laundry room. How about the supply line to your fridge's ice maker if it's pushed up against an exterior wall? And the biggest offender of all, the outdoor hose bib or spigot. So, what's the game plan? It's a multi-layered defense. First, insulation is your best friend. For any pipes in unheated areas like basements, crawl spaces, or garages, you need to wrap them. Foam pipe sleeves are cheap, and they're incredibly easy to install. You just cut them to length and snap them on. For pipes in really cold spots, you can level up to electric heat tape. This is a cable you wrap around the pipe that has a built-in thermostat. It only turns on when things get dangerous, giving just enough warmth to prevent a freeze. Second, on those brutally cold nights, let your faucets drip. Not a stream, just a slow, steady drip. This does 2 things. It relieves pressure in the line, and moving water is much harder to freeze. And while you're at it, open the cabinet doors under your sinks. This lets the warm air from your house circulate around the plumbing, keeping those pipes above that critical 32-degree mark. Number 2. Heating system failures. Moving on to number 2. The very system you're counting on to survive the cold, your heating system. A furnace, boiler, or heat pump failure is one of the most common winter emergencies. These systems work their absolute hardest during the coldest weather, which, just like a car, is exactly when they're most likely to break down. And usually, it's not the main unit itself, but a smaller, more vulnerable part that gives up the ghost. For a furnace, the typical culprits in the cold are the igniter or the flame sensor. The igniter is the part that glows red hot to light the gas. They're fragile and can crack. The flame sensor is a safety device that just confirms there's a fire. If it gets dirty, it can't see the flame and shuts the whole system down. For boilers, you can have issues with pressure loss or a problem called kettling, where mineral deposits cause pockets of water to boil, making a loud, banging noise. Heat pumps are a special case. They work by pulling heat from the outside air, which gets harder and harder as the temperature drops. Many heat pumps start to struggle below 40 degrees and need to call for backup, often called auxiliary heat. This backup is usually a set of electric resistance coils, basically a giant toaster inside your air handler, which are incredibly expensive to run. The big failures here are when the outdoor unit gets encased in ice and can't run its defrost cycle, or when that backup heat fails to kick on, leaving you with a system that's just blowing cool air. So, what's the proactive fix? It's all about maintenance. First, change your filters. I know, you hear it all the time, but it is the single most important thing you can do. A clogged filter chokes your system. It restricts airflow, makes it work harder, and can cause it to overheat and shut down. In the winter, you should be checking your filter every single month. Second, schedule a professional tune-up times before times winter hits. An HVAC tech will do a full inspection. They'll clean the flame sensor, check the igniter, inspect the motors, and on a heat pump, they'll check refrigerant levels and test those expensive backup heat strips. This is the checkup that can spot a failing part before it leaves you shivering on the coldest night of the year. The cost of a tune-up is a tiny fraction of an emergency service call. Number 3. Thermostat malfunctions. That brings us to number 3. The brain of your entire heating system, the thermostat. It seems so simple, but a faulty thermostat can make you think your whole HVAC system is shot when it's really just this one little device causing all the trouble. When it's freezing out, your thermostat is mission control, and its failure can be just as bad as a furnace blowing up. So what actually goes wrong? A few common things. First, and simplest, dead batteries. A lot of digital thermostats use batteries, and if they die, the screen goes blank and it stops talking to the furnace. Problem solved, right? The second issue is dirt. Over time, dust can get inside and coat the temperature sensor, basically giving it a little insulated jacket. The sensor can't get an accurate read of the room, so it might think the room is warmer than it is and never turn the heat on, or it might think it's colder and run constantly. The third problem is location, location, location. Is your thermostat near a drafty window? It's going to think it's colder than it is and run your furnace over time. Is it in a spot where the winter sun hits it directly? It might get warmed up and think the room is a comfy 72 degrees, while the rest of the house is an icebox. Finally, older thermostats, especially those old mercury switch ones, just wear out. They become uncalibrated and can be off by several degrees, leading to wild temperature swings. Here's your action plan for the thermostat. First, the easy one. Change the batteries. Make it a yearly ritual. When you change your smoke detector batteries, do your thermostat batteries. This one step can save you a no-heat call. Second, clean it. Turn the power off to your HVAC system at the breaker. Pop the thermostat's cover off. Use a can of compressed air, the same stuff you use for your keyboard, and gently blow the dust off the internal parts. Number 4. Air leaks and drafts, the invisible enemy. System number 4 isn't a machine, but it's a system whose failure makes all your other systems work themselves to death. I'm talking about your home's building envelope, specifically air leaks and drafts. You can have the best furnace in the world, but if your house is full of holes, you're basically just paying to heat the neighborhood. The Department of Energy estimates that sealing these leaks can cut your heating bills by 10 to 20%. Here's what happens. When it's cold outside, your house acts like a chimney. It's a phenomenon called the stack effect. Warm air rises and escapes through tiny gaps in your attic. As that air leaves the top of your house, it creates a vacuum at the bottom, which sucks cold air in through leaks in your foundation, around windows, and under doors. This is why the first floor often feels so drafty. Finding these leaks is the real trick. So, here's how you can become a draft detective. On a cool, windy day, turn off your furnace and any fans. Then, light an incense stick. Carefully carry that stick to all the usual suspects and watch the smoke. If it blows sideways, you've found a leak. Check these key areas. Around all your window and door frames, where the floor meets the exterior walls, right at the baseboards. Anywhere a pipe or wire goes through an outside wall, like under sinks. Electrical outlets and switch plates on exterior walls. And the attic hatch. This is often a massive source of heat loss. Once you've found the leaks, you seal them. For gaps around windows and doors, weather stripping is your friend. For bigger gaps around pipes, use expanding foam sealant. For smaller cracks in trim, a good quality, flexible caulk is perfect. And for those drafty outlets, you can get pre-cut foam gaskets that fit right behind the cover plate. They cost pennies and take seconds to install. Sealing these leaks makes your home more comfortable and takes a huge load off your furnace. Okay, we're 4 systems in. If you're already getting ideas that could save you from a disaster or just save you some serious cash on your heating bills, do me a favor and hit that like button and think about subscribing. We still have 5 critical systems left to cover, including the one that causes insane water damage from your roof. Your support helps me make more videos like this one. Now, let's get back to it. Number 5. Caulking and sealant failures. System number 5 is directly related to what we just talked about, but it's a specific material failure. Your exterior caulking. That bead of caulk around your windows and siding is your home's first line of defense against drafts and water. But caulk doesn't last forever, and cold weather is its worst enemy. Here's why. Most materials shrink when they get cold. The wood trim shrinks, the siding shrinks, and the caulk itself shrinks. If you have an old or cheap caulk, it gets hard and brittle in the cold. As everything around it shrinks, the caulk can't stretch. It either splits down the middle or pulls away from the edge. When that happens, you've got a brand new gap. It lets in cold air, but more importantly, it creates a direct path for water. When snow melts or you get a freezing rain, water gets behind your siding and trim, where it soaks the wood sheathing of your house, leading to hidden rot you won't find for years. So, how do you stop this? It's about inspection and using the right stuff. First, before it gets cold, do a slow walk around your house. Look at every window, door, and corner. Look for caulk that is cracked, peeling, or pulling away. If you find any, use a utility knife to cut out the old, failed caulk. Second, you have to use the right caulk for the job and the temperature. Most cheap acrylic latex caulks shouldn't be applied below 40 degrees. They just won't cure right and will fail almost immediately. If you absolutely have to caulk in the cold, you need a specialized product like a copolymer rubber or polyurethane sealant rated for low-temperature application. The best strategy, though, is to do this job in the fall on a mild day. This gives the caulk plenty of time to cure before the first deep freeze. When you're buying caulk, look for words like flexible or elastomeric. These have more give and can handle the expansion and contraction that comes with temperature swings. A small detail that will add years to the life of your home's exterior seals. Number 6. Sump pump freezing. Alright, let's talk about the disaster that started this whole journey for me. System number 6. The sump pump. This is a perfect example of a system where one part freezing causes a total failure somewhere else. For the sump pump, its Achilles heel is the discharge line. Here's the catastrophic chain of events. The pump sits in a pit in your basement, ready to pump out groundwater. It sends that water out through a discharge line that runs outside. During a hard freeze, leftover water in the last few feet of that outdoor pipe can freeze solid, creating an ice plug. Your sump pump has no idea. So, when the ground thaws a bit and the pit fills with water, the pump kicks on. It tries to push water against a solid block of ice. The motor just runs and runs, getting hotter and hotter until it burns itself out. Now you have a dead pump and a basement that is actively flooding. Preventing this is absolutely critical. The best solution is a properly installed discharge line that's buried and sloped downwards, so gravity drains all the water out. But if you already have a line that you think is a problem, you have options. The simplest is to wrap the exposed part of the pipe with insulation or heat tape. A better solution is to install a specialized freeze guard fitting. This is a device that gets installed on the discharge line on the outside of your house. It has vents in it. If the main line freezes and gets blocked, the water is automatically rerouted out of these vents. It provides a backup escape route, which saves your pump from burning out and keeps your basement dry. It's a relatively cheap upgrade that's a total lifesaver. Finally, make sure the discharge line is carrying water far enough away from your house. At least 20 feet. Use a rigid or semi-rigid extension hose, not a flexible, corrugated one that can hold water in its low spots and freeze. Taking care of your sump pump's discharge line is a winter prep step that is too often overlooked. Number 7. Roof and gutter problems, ice dams. System number 7 is one of the sneakiest and most destructive winter problems, ice dams on your roof. An ice dam is a thick ridge of ice that forms at the edge of your roof and in your gutters. It might look pretty, like a winter postcard, but it's actually a sign of a serious problem that can cause thousands in water damage. Here's how it happens. You need 3 things: snow on your roof, freezing outdoor air, and heat escaping from your house into your attic. That escaping heat warms the underside of your roof, melting the bottom layer of snow. This water runs down the roof until it hits the eaves, the overhang. Because the eaves aren't over your warm attic, they're still freezing cold. The water refreezes right there. As this cycle continues, a ridge of ice, the dam, builds up. Now, all the meltwater running down your roof gets trapped behind this dam. This standing water has nowhere to go but up and under your shingles, seeping into your attic. From there, it ruins your insulation and leaks into your ceilings and walls. Ice dams are not a gutter problem. They are a heat loss problem. The long-term fix is to deal with the heat loss. First, you need to air seal your attic floor. Just like we talked about with drafts, you have to stop warm air from getting into the attic in the first place. Seal up gaps around vents, wires, and light fixtures. Second, you need more insulation in your attic. Most homes in cold climates should have at least 12 to 18 inches of it. If you can see the tops of your ceiling joists, you don't have enough. Adding more will help prevent ice dams and dramatically lower your heating bills. Number 8. Frozen ventilation systems. Number 8 is a system that a lot of modern, energy-efficient homes have, but it's often a complete mystery to the homeowner. Your mechanical ventilation system, like a heat recovery ventilator, HRV, or energy recovery ventilator, ERV. In a modern, airtight house, these are the lungs of your home, constantly swapping stale indoor air for fresh outdoor air. To save energy, they pass the two air streams through a core that transfers heat from the outgoing air to the incoming air. The problem is, when it's freezing outside, the warm, moist air from your house hits the frigid surfaces inside that core and freezes. This ice can build up until it completely blocks airflow, essentially suffocating your house. This not only stops fresh air from coming in, but it can trap humidity inside, leading to major condensation on your windows. So, how do you keep your home's lungs from freezing? Thankfully, manufacturers know this is an issue, and most units have a built-in defrost strategy. You just need to make sure it's working. Some units have a damper that will periodically close off the cold incoming air to let warm air melt any frost. Others will recirculate indoor air to warm the core. Your job as a homeowner is to help it do its job. First, read the manual for your HRV or ERV. Understand its defrost mode. Second, just like your furnace, these systems have filters that need to be cleaned or replaced. Clogged filters reduce airflow and can make freezing problems even worse. If you find that your system is repeatedly freezing up, you need to call an HVAC pro who specializes in ventilation. Ignoring a frozen ERV means your house isn't breathing. Number 9. The overworked HVAC system, cumulative failure. We finally arrived at number 9. This isn't a single part that breaks, it's a systemic failure. It's the slow, silent killer of your entire heating system, the overworked HVAC. This is the final, expensive result of a home that isn't ready for the cold. Think of it like this. Every draft from a bad window seal, every bit of heat leaking through your attic, every crack in your caulk, each one is a small wound. Your furnace or heat pump is the heart of your home, and it has to work harder and longer to make up for all that lost heat, just to keep the house at the temperature you set on the thermostat. This constant, relentless workload puts immense strain on every single component. The blower motor runs for hours, wearing out its bearings. The igniter cycles on and off more often, shortening its life. On a heat pump, the compressor, the single most expensive part, is put under incredible stress. This isn't a sudden failure. It's a death by 1,000 cuts. The system that was designed to last 15 or 20 years might now only last 10. And that failure will almost certainly happen during the worst cold snap of the year, because that's when the system is already pushed to its absolute limit, and one tired part finally gives out. The solution to this final boss of a problem is to embrace the philosophy of this entire video. See your house as one interconnected system. The check for this is to just be observant. Is your furnace running constantly? Are your energy bills shockingly high? Are you hearing new squeals or grinding noises? These are all cries for help from an overworked system. The fix is to go back through our list. Change your filters so it can breathe. Seal your air leaks so it's not fighting the outside world. Beef up your insulation so the heat you paid for stays inside. Get it professionally serviced so it runs at peak efficiency. Make sure your thermostat is talking to it correctly. By taking care of all these smaller issues, you are directly extending the life of the single most expensive and critical appliance in your home. You're not just preventing one failure, you're preventing the premature death of your entire heating system. So, there you have it. The 9 systems in your home that are secretly at risk when the temperature drops. We've covered water pipes, the heating system and its brain, the thermostat, the invisible enemies of air leaks, and the threat of ice dams. We've looked at the subtle but critical failures of your caulking, your sump pump, and your ventilation system, all leading to the slow death of an overworked HVAC system. Winterizing your home is about so much more than just dodging a burst pipe. It's about making sure your family is safe and comfortable. It's about protecting the massive investment you have in your property. And it's about peace of mind, knowing that when the temperature plunges, your home is a secure, warm fortress. The checks and simple fixes we talked about today are some of the highest return investments you can make. They take a little time now, but they can save you an incredible amount of money and stress down the road. I hope you found this guide helpful. Now I want to hear from you. What are your own winterizing tips? Is there a system I missed or a hard-learned lesson you can share? Drop it in the comments below. Your experience could save another homeowner from a disaster. If you're ready to take your home maintenance to the next level, check out my playlist on total home preparedness right here. And if you haven't already, hit that subscribe button for more in-depth guides to keep your home running smoothly. Thanks for watching, stay warm, and stay safe.